Okay, let's start. Okay, thanks to Schrödinger for inviting me to accept my talk, and thanks Nana Bianca for this cool location. Okay, the title of my presentation is Scaling IoT Development with Zephyr, an embedded system OS for the future. Okay, there are a lot of buzzword IoT, Zephyr, embedded system. I will explain all this stuff. Okay, let's start with me, some self-promotion, okay? I'm Leonardo Cavagnis, I'm a firmware engineer in Arduino. In Arduino, I develop library, core, and stuff related to IoT, connectivity stuff, Edge AI, and other cool stuff. And also, I have a passion for sharing knowledge to convert complex technology in something that is clear. Okay. I do that with writing. I have a Medium blog in which I write stuff about IoT firmware development. And I share content on my LinkedIn page, and I'm part of a community that is called Italian Embedded Community that connect experts in the embedded system field. And I love to share my knowledge through talks in conferences like this one. Okay. Okay, stop for self-promotion. Okay, now we can start with the interesting stuff. I will introduce what is an embedded system, then what are the approaches in the embedded firmware developer. Then I will explain what is an operating system in embedded, and last but not least, I will explain what is Zephyr. Okay, how many firmware engineer, embedded system engineer, embedded developer in this room? Oh, wow. Okay. Okay, I start with a crash course in embedded system. Wow. Embedded system 101. Okay, let's start. What is an embedded system? How many of you do you know what is an embedded system? Okay, that's fine. Okay, an embedded system is a computer. It's a computer system designed for specific tasks. Okay, our laptop is a general purpose computer. Instead, embedded systems are special purpose computing systems that are built for specific tasks, like, for example, a camera, a washing machine, a drone, because they are systems designed to perform specific tasks, like, for example, washing clothes. The brain of an embedded system is microcontroller, is the microcontroller unit. It's the brain of an embedded system. In an embedded system, you can find more than one microcontroller. But in general, you have a main microcontroller and then other microcontrollers. What is a microcontroller? Microcontroller is the brain, so it controls the hardware and processes the data. Okay, we can summarize an embedded system with three blocks: sensor, microcontroller, actuators. With the sensor, an embedded system senses the world, so capture data from the environment, from the user. The microcontroller elaborates this data, and then react in the real world through actuators. What are actuators? Like, for example, an actuator is a motor, a relay. So react in a real environment. So, okay. A microcontroller is a system inside a chip, because a microcontroller is composed by the central process unit, okay, the microprocessor, and then the memory, RAM, and peripherals. What are peripherals? Like, for example, the input-output peripheral, the digital analog converter, the analog to digital converter, so the peripherals. Okay, how can I talk with this microcontroller? How can I program this microcontroller? I program this microcontroller with firmware. Okay, I'm a firmware engineer, so I write what? Low-level software. What is a low-level software? A low-level software, a firmware, is a software that runs on a microcontroller, and then they directly control another device. Okay, you can program a microcontroller in two ways, with two approaches. The first approach is called bare metal. In a bare metal approach, you don't have an operating system. You control directly the hardware, so the register. So you write the bit. You write the most difficult stuff. So you write with the hardware. This approach is lightweight, it's fast and deterministic because you control directly the hardware. But it's complex because it requires manual management of resources, task and timing. There is another approach that is more simple and that abstract. There is an abstraction layer, and it's called an OS-based approach. So an embedded system for an operating system for embedded system. In embedded system, we call this OS RTOS, real-time operating system. What is a real-time operating system? A real-time operating system is an operating system designed for embedded system. So it's designed to run on resource-constrained device. What are the main features of an RTOS? The scheduler. With the scheduler, you can run multiple tasks. Instead, in a bare metal approach, you run a single task, a single big program, a while true loop. In a real-time operating system, the real-time words means deterministic behavior, because each task in a RTOS has a predictable response time. It means that each task has a deadline, okay? Because we have tasks that do critical operation. In RTOS, we can use inter-task communication, like in other operating systems, like, for example, sharing mechanisms like multitasks, semaphores, and other. And an operating system for embedded system has a good power management because it's optimized to run in a low power CPU. And an approach to okay. Sorry. Okay. In RTOS, when a task is not executed, is removed from the memory, and then you waste few memory, you waste few power. Okay. There are a lot of RTOS, like for example, there are open source RTOS and proprietary RTOS. The most famous RTOS is the free RTOS, developed by Amazon Web Service open source, and it's one of the most widely used RTOS. And then there is Zephyr. Zephyr is developed by the Linux Foundation, and it's gaining traction recently in various industries, like for example in the IoT context. There are also proprietary RTOS, like for example ThreadX by Microsoft, WixWorks by WindRiver, and Neutrino by BlackBerry. Okay, Zephyr. Zephyr is the name of a spring wind. And it's a name of an open source and community-driven RTOS. It's a real-time operating system developed by Linux. So imagine how it's large, it's broad, the community. The promises of Zephyr is to be scalable, secure, and modular, because we have to use this operating system in a low-power system up to complex IoT gateway. And another promise of Zephyr is to be compatible with with a wide, broad hardware support, hardware range of microcontroller, from MCU to system on chip, multiple architecture, and more. Okay, what is Internet of Things? Internet of Things, it means that give internet, so give connectivity in general to devices. So why we have to choose Zephyr for IoT? We have to choose Zephyr IoT because Zephyr implements a rich connectivity stack. It's a security-first approach OS. It's designed for modularity scalability, and in the next few slides I will explain what does it mean. And because there is a strong community support, because it's supported by the Linux Foundation. Okay, let's start with the rich connectivity stack. What does it mean? It means that Zephyr OS implement as a native support for IoT and communication, and implement the most common communication interfaces, like for example Bluetooth Low Energy, Wi-Fi, Thread, LoRa, MQTT. In general, in a bare metal approach or in other operating systems, you have to install external library. So you have to depend from external library to use Bluetooth Low Energy, Wi-Fi. Instead, Zephyr OS born with embedded connectivity. So just to enable or disable the connectivity you want. Another great feature of Zephyr is the advanced security model. So Zephyr implements encryption. Algorithm encryption is compatible with the most common encryption algorithm. So you don't have to install external libraries to use encryption algorithm. it implements a secure boot. It means that only authorized firmware can run on a device. It's possible to implement a strict access control to the system resources, and it's compatible with hardware-assisted security. What does it mean, hardware-assisted security? In most recent microcontroller, the vendor add a specific component to use to implement secure algorithm. Zephyr is compatible with this chip that implement hardware cryptographic accelerator, and not only. Okay, scalability and modularity. Zephyr is efficient and scalable. What does it mean? That it's possible to enable, disable feature based on your project need. So you can implement Zephyr in a low power MCU up to complex IoT gateway. Zephyr is also flexible. What does it mean? That implement an over-the-air update for remote management, so you can install remotely through connectivity the firmware. In a bare metal approach, you have to implement at your own the over-the-air update. It's not an easy task. And another great feature of Zephyr is that it's has a modular architecture, and it's based on a device tree structure. What is device tree? Device tree is a set of files that describe the hardware. It means that the code is the same, so it's possible to port. The code is portable. The Zephyr code is portable. You have only to change the device tree, so the hardware implementation. It's an important feature in firmware development and embedded system, because in general, with the bare metal approach, the firmware, the software, depends strictly from the hardware. Instead, with this approach, just to change the device tree, and then you can move your code from a microcontroller to another microcontroller. Another great feature is the built-in driver. So Zephyr OS includes the most common driver for sensor, motor, display, and more. And thanks to device tree and kconfig, it's easy to add custom driver for a specific sensor. Last but not least, it's the ecosystem and community. Zephyr is open source and is supported by Linux. So imagine how it's large, how it's wide the community behind. There is an engaged community with forum support channel. You can find a lot of documentation and tutorial on how to run Zephyr on microcontroller, on electronic board. And last but not least, it's supported with the major tech company, embedded system tech company, like for example Intel, ST Microelectronics, and Arduino. Okay, but why Zephyr is so powerful? Because the kernel, it's a microkernel. What is a kernel? The kernel is the core component of IoT OS that is responsible to manage tasks, resources, and services. Zephyr has a microkernel. It means that the microkernel implements only the essential stuff. And then if you want to add peripheral and other stuff, you have to add. So it's the modularity feature of Zephyr. Instead, like for example, the competitor, the FreeRTOS, has a monolithic kernel. So it's not possible to disable single feature, but you have to take the monolithic kernel and then install. So the size of the kernel don't change. Instead, in the microkernel, you can change the size of your OS depend from your system. These are other differences between Zephyr and FreeRTOS. In Zephyr, you have a direct modularity thanks to the microkernel. You have a more advanced scheduler. So Zephyr is more complex. Zephyr is more complex to manage tasks, but we have a more advanced scheduler, because in FreeRTOS you can manage only the priority of a task. Instead, in Zephyr, you can manage a lot of things in task management. Okay, what is Arduino? How many of you know what is Arduino and use Arduino? Wow, great. Okay, Arduino is an electronic board, right? Yes, it's an electronic board. No, No, not property. Okay, Arduino is an Italian company. It's a global leader in open source hardware and software. In Arduino, we don't create only electronic boards. We create a complete platform for making interactive project, not prototyping, but project in general. What is platform? We create a platform composed by hardware, software, integrated development environment, cloud. We have a lot of stuff to create project. What is an interactive project? An interactive project is a project in which you interact with mechanics, with electronics, with the real world, with the user. So you can create the thing you want. In Arduino, this platform is designed to be accessible to all. And there is a large and active community on Arduino. So there are over 30 million developers in the world that use Arduino. Okay, what is the mission Arduino? The mission Arduino is to enable anyone to innovate by making complex technology simple to use. But who is anyone? Anyone are student, maker, and business. We have a business unit that is called Arduino Education. This is intended for school and to teach electronic and programming language to students. Then we have the maker, so for nerd people, to create project to solve real world problem in your home or your company or what you want. And then we have a business unit that is called Arduino Pro that we help businesses to solve business use case with our platform. Okay, how we implement Zephyr in Arduino? Zephyr has two approaches with Arduino. Zephyr OS has a native support for Arduino board, so you can use directly Zephyr directly to some of the Arduino board. But there is another approach. If you don't want to use directly Zephyr, you can use the Arduino Zephyr approach. What does it mean? That we have implemented Zephyr in the background in the board. So you use the classic Arduino Sketch experience, but Zephyr run in the background. So you write the typical setup loop function, and then you use the typical Arduino approach. How it works, Zephyr in Arduino? In Arduino, we have, okay, in Arduino board, the traditional flow is the sketch. The sketch is the Arduino program. You compile the sketch in a standalone library with all the stuff inside, and then you load this sketch, this program, on the microcontroller through the bootloader. The bootloader is a very, very, very simple and small program installed in the microcontroller that takes the Arduino sketch and install the sketch in the memory, and then run the program. With Zephyr, we have used a different approach. In the microcontroller, we have a Zephyr loader. The Zephyr loader is not a bootloader. It's a big program that embeds the OS, the kernel of Zephyr. When you compile the sketch, you compile a very light program that embeds only the stuff you need, and then you send this program to the Zephyr loader, and then the Zephyr loader dynamically take the program and then run the program, implement all managing all the Zephyr TOS stuff. So you use Arduino, and you don't know that inside there is Zephyr, but you take advantages of the powerful of Zephyr. So the responsibility of Zephyr are managing the sketch and then handle the hardware stuff inside. So the Zephyr loader manages the device tree to talk with the hardware, to talk with the microcontroller. Okay. The takeaway, summary. So in a embedded system, as in other field, we need a scalable solution. Because we need a scalable solution, because we have low power MCU up to complex IoT gateway. And Zephyr is a powerless solution for IoT project because we have the flexibility of the bare metal approach, because you can enable and disable what you need. But we have the advantages of the TOS. If you are interested in working with Zephyr, you can go to the official documentation that is wide, simple to understand, and easy to learn. And if you want to contribute to our core, you can go to github.com Arduino core Zephyr, and then you can help to improve our Arduino core for Zephyr, because at the moment it is in the beta version, but it works. Okay, if you are interested in more about Zephyr OS in Arduino, I recently, yesterday night, I finished to write this article on my Medium page. Okay, these are my contacts. Grazie.
Thank you, Leonardo. You work in one of the coolest part of the industry, in my opinion, but just my opinion, I don't know if anyone thinks that I'm correct, but...
Yeah, so we have some time to take some questions for you. Before we do, don't forget that asking questions is part of the gamification process. And if you're wondering how to get involved, if you turn over your attendee badge, there's a QR code that you can scan, and that should help you to have access. So, does anybody have any questions? Yep.
Don't be heavy.
We'll bring the microphone to you.
Okay, non-technical question, but I couldn't get any of the Zephyr maintainers to tell me the answer. Why is there a kite as the icon for Zephyr?
Because Zephyr is a wind, is a spring wind. So it means that there is a kite.
Okay, all right, cool.
Yeah, asking the important questions. Anybody else? Equally important questions. Yeah, we have one at the back. Long walk.
Not that I know much about embedded systems themselves, but I do have a question about the languages you use in Zephyr OS. Why do I ask? Because generally it is C, either C or some assembly language. But now there is Rust, Zig, all of those new languages. Is Zephyr OS also thinking about using those like Linux is already doing with Rust? Or are you sticking with C, for instance, or C++ for what matters?
Zephyr at the moment is implemented in C and C++.
Mm-hmm.
Okay.
And do you have an idea on even considering one of the new languages, or you think that it doesn't matter?
I don't know. I don't know, but there is more interest in the embedded system world to use Rust. But at the moment, Rust is a very, very small part.
Yeah, like kind of like Linux, although they are trying to adopt it a little more. I get you. Thank you very much.
Thanks for the question.
I think we had a couple more down here. Long walk all the way back.
I'm going to do a marathon today.
Getting your steps in.
Question. If I have an old Arduino board, can I run Zephyr on it, or do I need to buy a new board because it's more heavy and I need a more powerful board?
No. At the moment, it's a beta version, and there are some boards compatible with Zephyr, but the willing is to be Zephyr compatible with all the Arduino boards, because Zephyr is modular, so it's light, so it's possible to install Zephyr in a low-power Arduino board. So just to install the Zephyr loader, you can go to the Arduino docs, and then you will find the documentation about how to install in your board Zephyr and use it. What board do you have?
Arduino 1 board.
Arduino Uno?
Sì,
Uno R1, R2, R4, R3, you don't know?
No, it's quite 5 years old, something like that.
Okay, R2, R1, okay. Mm-hmm. At the moment, it's not compatible, but in the future, I will.
Okay, I will buy a new board. Thanks.
Amazing. Did I see another hand? Yeah, at the back here.
Hello, thanks for the talk. I would like to more details about how OTA security is implemented.
How security is implemented is the question.
For the OTA updates, OTA.
I don't get the question. So the question is technically how the security is implemented.
How the OTA updates for the how you verify updates for the modules over the year?
Okay, how to verify. Okay, in Zephyr there is a secure boot, so you can create a cryptographic key, and then you can create an authorized Zephyr OS loader, and then when you create your firmware, you sign this firmware with your private key, and then you send this firmware to the Zephyr loader, and if the private key is correct, you can install the firmware. Otherwise, the Zephyr loader will refuse the firmware. Okay?
Thanks.
You're welcome.
Amazing. I think if anybody else has any questions, we do have time. No, I think that might be everyone. Okay, thank you again for the amazing talk. And the moment that you have been waiting for, we do have your Schrödinger Award as well for contributions to open source and being here today.
Here are your trophies for being an open source champion.
Amazing.